Hello everyone, my name is Choyoje. Today, I would like to introduce a game I created. I will be sharing what inspired me to develop it, its key features, and how it works. I hope you will find it interesting. What motivates me to design my own game? The first reason is my passion for gaming. As a game lover, I have played many games on both my phone and computer, such as Minecraft, Arena of Valor, and Valorant. I have always wondered how these games were made, so I wanted to do more than just play. I want to create a game myself. The second reason is my curiosity. I have always been interested in how different game mechanics and systems work together. Making this game gave me a chance to explore this concept and better understand game development. This is my development workflow. First, I familiarized myself with Unity. Then, I followed the cycle, referring to online tutorials, constructing game elements, writing scripts, and integrating them into objects. I repeated this process until the game was complete. Now, let me introduce game engines and Unity. A game engine is a framework for developing games. Why do we need to use them? First, they provide a ready-made development environment, allowing developers to work more efficiently. Second, game engines come with numerous built-in functions, reducing the need for extra work. Moreover, they enable games to run across multiple platforms. For example, Genshin Impact is often considered a mobile game, but thanks to Unity, it can also be played on computers. These are the key aspects of my game. The theme of my game is three-dimensional parkour. Parkour is a sport in which participants navigate various obstacles to reach the final point. My first idea was to add different effects to blocks. Another concept was to explore various mechanics, such as the particle system and scene transitions. The key to bringing these ideas to life is triggers, a feature in C#. My game consists of 3 levels. Here is an overview of level 1. As you can see, it is a very basic challenge. The player simply jumps across multiple white blocks to reach the yellow block, which serves as the level 1 final destination. In level 2, I introduced 2 new types of blocks. Blue blocks are arranged in the middle layer, while floating blocks are positioned above them. These floating blocks move up and down. In level 3, I introduced 2 more types of blocks. Black and white blocks are arranged in an alternating pattern, forming a grid-like structure. At the center of this grid is an elevator with particle effects, which carries the player to the final platform, marking the end of the game. Let's take a look at the different block types. The basic one is the pure white blocks with no special effects. The endpoint is a yellow block that transports the player to the next level. The jump boost is a blue block that emits cube-shaped particles. It enhances the player's jump height. The floating platform is a flat, platform-like block. Players can stand on it and move as it floats. Next, the teleport is a black block that instantly transports the player back to the start upon collision. The elevator is a white block with two upward flowing spiral lines. If the player stands on it, it will carry them to the end. Now, I'm going to explain how I implemented these effects. The teleport effect allows an object to be transported to a designated position, such as black or yellow blocks. This flowchart illustrates their mechanics. Let's start with the endpoint block. When an object enters the trigger zone, the script detects whether it is the player. If so, the player will be transported to the target position, the next level. As you can see, in this grid, a pair of black and white blocks will swap positions. In total, there are 4 pairs of black and white blocks exchanging position with each other. This movement creates a rotational visual effect. The next is jump boosts. When the player enters the trigger zone of a blue block, their jump height is temporarily increased. However, the effect only lasts until the player exits the zone. How does it work? The script modifies the player's y-axis velocity to 15 float, providing a temporary boost. The key to the floating flag effect is the sign function. First, the script assigns each floating block a random oscillation range and speed, ensuring that every block moves uniquely. Then, the script continuously executes a loop, calculating the current phase, setting the current position, and moving toward the target position. What is a phase? Phase represents the stage of periodic variation. You can see the diagram. It's a sine wave graph where the height fluctuates over time. My script utilizes this function to create the flow effect. Next is the elevator. It detects when the player enters the trigger zone, and if the player remains on it continuously, it will keep moving toward the final platform. However, once the player leaves the trigger zone, the movement will be interrupted, and the elevator will return to its original position. On the next page, I will introduce other mechanics I implemented. The first is the basic particle system. The blue blocks emit numerous cube-shaped particles, and I made some adjustments to refine their appearance. First, I applied the color over lifetime setting. From generation to disappearance, the cubes gradually exchange from white to transparent, creating a smooth gradient effect. Additionally, I utilized an advanced function, post-processing, to make particles bloom. This effect can be easily achieved through the Unity hierarchy settings. The spiral particle effect is more complex, so I had to script it manually. First, the system assigns each particle an index using an array and determines whether it is odd or even. This classification separates the particles into 2 groups, odds and evens, which are then positioned on opposite sides of a circle. Next, the scripts calculate the current phase and move the particle toward the target position. The second mechanic is scene transition. Take the play button as an example. When the player clicks the button, the main menu becomes inactive, and the game scene loads. The options and exit buttons function in the same way. The third mechanic is the timer. If the remaining time is greater than 0, it continuously decreases over time. When time runs out, the text "Game Over" appears, and after 3 seconds, the scene transitions back to the main menu. Finally, these are my future prospects for this Parkour game. First, I plan to design additional levels with increasing difficulty to enhance the gameplay experience. By expanding the level variety, players will encounter more engaging and diverse challenges. Second, to improve the game's aesthetic appeal, I plan to add custom textures, models, and lighting effects to make the game more immersive. Lastly, I want to provide players with a complete game experience. I aim to implement additional features such as background music, sound effects, and level selection to enhance sensory engagement and immersion. That's the end of my presentation. I hope you found it engaging and got a better understanding of how I developed this game. Feel free to ask any questions. Thank you for listening.